All right, these are the answers to the page 522, kind of getting a look at some different integration methods that we're going to use. For number 3, they wanted to know if we were to integrate here, what would this integrate into? And it might be tempting to think of this in terms of a arctangent, because you see the x squared plus 1, and that would be true if there was a 1 up here, but it's not. We have that x there. And because we have the x there, we could think about doing a u sub here and having x squared plus 1 be that u, right? So if I have u equal to x squared plus 1, then du would be 2x dx, and I would have dx equal to du over 2x. And when I do that subbing, those x's will cancel. I'd have a 1/2 that comes out, so I'd end up 1/2 times the integral of 1 over u du, which would turn into natural log of the u, and then plus c. Now, if you got to there, you're looking and you're saying, well, I don't see that anywhere, and that's because this 1/2 could come up, become the exponent on the x squared plus 1, which would turn it into the square root. So A is our choice on that one. Okay, so it's a little bit of a u sub, and then you have to do a log rule to kind of get to where we want to be. For 17, it's also a u sub. I see z minus 4. We're going to let that be the u here. And du will be dz. No worries there. We can just do a quick sub on that one. So I'm going to pull that 5 out front, and we're going to have 1 over u to the 5th times du, which is 5 times the integral of u to the negative 5th du. And so if I integrate that, I'm going to go up 1, so it'll be u to the negative 4 over negative 4 plus c. And then if I kind of finish up that idea, it's negative 5/4 times z minus 4 to the negative 4 plus c. So just a u sub, nothing special there. 21, also looking at that, and I've got a bunch on the bottom. The top degree is less than that, so I should be thinking kind of u sub first. So if I go u on this one, I'm going to let the whole bottom be the u on this. All right, and so du would be negative 3t squared plus 9 dt. And if I pull, when I go to divide that, I'm going to go ahead and pull a negative 3 out, which will give me t squared minus 3. And that's important, because then when I come back over here, I'll have the integral of t squared minus 3 over what I'm making u now, times du over negative 3t squared minus 3. The t squared minus 3's cancel. I can pull that negative 1/3 out, 1 over u du. So that turns into negative 1/3 times the natural log of the absolute value of u, which is negative t cubed plus 9t plus 1 plus c. So far, everything's been kind of a u sub. Then we get to 23, and I can't u sub anymore. I can't make x minus 1 the u. The x squared wouldn't go away. I could try to maybe do some type of thing where I resub in, but that gets real tricky. So probably the best thing to do is when I see the degree on the top is bigger than the degree on the bottom, the best thing to do is to do a long division. So I'm going to take x squared, I'm going to divide it by x minus 1. So the question is, what would I have to multiply x by to make it equal x squared? And that would be an x. Then I go ahead and multiply. X times x is x squared. X times negative 1 is negative x. Subtract, those cancel. 0 minus negative x is a positive x. Okay? So what do I have to multiply x by to make it equal x? Just 1. Multiply, I get x minus 1. Subtract, nothing minus negative 1 is a positive 1. So when I bring this up, I'm going to bring it up as a fraction, like that. So in other words, this expression, this x squared over x minus 1, is the same as x plus 1 over x minus 1. Okay? So now, instead of integrating this, which I didn't know how to do, I'm going to try to integrate these pieces. The integral of x is x squared over 2. The integral of 1 is x. And the integral of 1 over x minus 1 is the natural log of the absolute value of x minus 1 plus c. So this long division can pop up on the AP from time to time, and the key is the top degree bigger than the bottom? If so, that's the way we want to go. Okay. 27 I threw in just to kind of see the limits of what we can and can't do. If you thought about a u sub, maybe you took this whole 1 plus 2x squared as the u. The problem is that when we do the du sub in, we're going to have extra terms that we don't want. There's really nothing to divide here. This isn't an arctan or arcsine, so we're kind of running out of ideas. The only thing left to do would be to consider working that square out. Can we FOIL this out? In other words, can we go 1 plus 2x squared times 1 plus 2x squared? And if we do that, we get 1 plus 4x squared plus 4x to the 4th. So if you FOIL that out, you get these terms, and we can do those terms. This is going to be x plus 4x cubed over 3 plus 4x to the 5th over 5 plus c. And that's our answer. Now we get to 75. And if I think about u sub, the problem is if I do the whole bottom as the u, I'm going to get a 2x plus 4 in the dx part, and there is none of that to cancel out. So you're going to have extra stuff if you try to do a u sub. This doesn't have the square root, so arcsine's kind of out. The only other option that's available to us would be an arctangent. And an arctangent needs to have something like x squared plus a squared or something like that. Got to have something in this form in order to fit it into the arctan formula. So in order to do that, we're going to complete the square. In other words, I'm going to look at x squared plus 4x, and I'm going to say, well, what would I have to have next to 4x to make that a nice perfect square? And that would be a 4. Get that by taking half of the middle and squaring it. Half of 4, 2 squared is 4. Well, I had 13. I'm going to take 4 of it for here, and that's going to leave me 9 left over there. Okay? So we're almost there. We're going to now factor that out. That's going to factor into x plus 2 squared plus 9. Okay? So look at that. Think about what the u would be, what the a is. Okay? And you can kind of see that our u part would be the x plus 2, and the a part would be 3. Right? So once we have that understood, sorry about that. All right, once we have that part understood, then we can go ahead and do the arctangent. The arctangent says take 1 over a, so 1/3 times arctangent of u over a, x plus 2 over 3 plus c. So we want to get it into this expression of x squared plus number squared. Once we have that, then it fits into the form pretty easily.